Hello and welcome to my channel, Curious Minds, to another fascinating journey into the mysteries of our planet. Today, we embark on a quest to unravel the profound significance of Earth's axial tilt. Join me as we delve into why this seemingly subtle tilt is far more important than we may realize. Picture this: it's December and the Northern Hemisphere is experiencing the winter solstice. But have you ever wondered why we have seasons in the first place? The answer lies in the Earth's axial tilt, a feature that plays a crucial role in shaping our climate and the course of life on our planet. Our journey begins with the fact that Earth's tilt is approximately 23.5 degrees. This tilt is responsible for the seasons we experience, but its influence goes beyond that. As we explore the intricacies, we'll uncover the profound impact this tilt has had on our history, biology, and even the evolution of intelligent life. To understand the origins of Earth's tilt, we must rewind over 4 billion years to a monumental event. A planet, nicknamed Theia, collided with the early Earth, resulting in a significant tilt and the formation of our moon. This collision set the stage for the unique conditions that allowed life to flourish. Now, let's contemplate an alternate scenario, a hypothetical Earth without a tilt. What if the axis were perpendicular to its orbital plane? Brace yourselves for a world where seasons as we know them cease to exist and every location receives a consistent amount of sunlight year-round. Without the axial tilt, temperature and precipitation patterns would remain stagnant, leading to a planet with stratified climate bands. The absence of distinct seasons would reshape ecosystems, affecting plant growth, animal behavior, and the very fabric of biological evolution. As we consider the potential impact on human civilization, we ponder a world where the development of technology might never have occurred. Cold weather, a driving force behind technological advancements, could be absent, potentially altering the course of history and the rise of our highly advanced society. In a thought-provoking twist, we explore the possibility of Earth turning into a snowball, a chilling scenario where the absence of tilt triggers a positive feedback loop, gradually encasing the planet in perpetual ice and altering global climate dynamics. Reflecting on the incredible journey, we express gratitude for Earth's tilt. It's a celestial gift that has shaped the very essence of our existence. As we marvel at the complexities of our planet, let's appreciate the unseen forces that make our world a truly unique and habitable place. We celebrate the winter solstice in December. It is the point in the Earth's orbit where the tilt of the northern hemisphere toward the sun is greatest. It is traditionally observed on December 21st or 22nd and is regarded as the start of winter. As we approach the summer solstice on June 20th or 21, the length of each day gets longer every other day. It is said to be the first day of summer on this day, since the northern hemisphere is at its most inclined toward the sun. Why are these solstices occurring? The reason for this is that the Earth has an axial tilt of roughly 23.5 degrees, as this video illustrates. The seasons and temperature of our planet are shaped by this tilt, but life on Earth was also greatly influenced by it. What would have happened, one could wonder, if the Earth had no tilt? Is a planet's tilt even typical? What led to it? If there were no tilt, you might be surprised by some of the ramifications for Earth and us humans. Let's examine the possible consequences of it. That is about to happen. In case you were unaware, the Earth has an axial tilt that has a significant impact on its orbit around the sun. It explains why the seasons in the northern and southern hemispheres differ. Is a planet's tilt even typical, one could wonder? Well, it seems that way. In our solar system, it is present on most planets. The only planet with almost no tilt at 2 degrees is Mercury. There is a 23.5 degree tilt to the Earth. Why is the Earth slanted in the first place? For every planet, the details are generally distinct. In the instance of Earth, it is believed that a planet about the size of Mars, which we now name Theia, collided with Earth early in its development more than 4 billion years ago and threw it off balance. As a result, some debris from the two planets was launched into orbit around Earth, and over time it formed into the moon. Additionally, the Earth's spin was permanently tilted due to this impact. I should emphasize right now that this is just a theory. Other than computer simulations which suggest that such a collision is necessary to explain the moon's current composition, orbit, and inclination, we don't have a lot of concrete evidence. However, the history of Earth has been significantly impacted by this axial tilt. There would be a number of important changes if Earth's axis was perpendicular to its orbital plane, meaning that there would be no tilt at all. The lack of the seasons as we know them would be the most obvious alteration. The 4 seasons result from variations in the length and strength of sunshine at various latitudes throughout the year, which are caused by the tilt. Everywhere on Earth would enjoy continuous sunlight for roughly 12 hours every day if there were no tilt. Because of this tilt, the sun's rays fall on the northern and southern hemispheres at various angles throughout the year, resulting in seasonal variations in both temperature and precipitation rates. Thus, there would be little variation in the patterns of temperature and precipitation without this tilt. The equator would still be warm and the poles would still be freezing. Researchers believe that stratified climate bands might exist on an untilted Earth. As you made your way farther from the equator, these bands would get progressively cooler. Humans may gather near the middle of the Earth where the climate is more like the tropics, as they may find life hard in the perpetual winter of the high latitudes. Since most tropics have little variation in temperature and day length throughout the year, they can provide as an example of what an Earth without seasons would be like in these non-tilting equatorial regions. It should be noted that there would be some variation in the weather. Because of the Earth's elliptical orbit, which brings it roughly 3% closer to the Sun at certain times of the year, there would be some alteration. Intriguingly, at the moment, Earth's wintertime proximity to the Sun is greater than its summertime distance. This should indicate to you that the tilt, not the distance from the Sun, has the greatest effect on temperature. Weather patterns, including storm development and precipitation, are influenced by seasonal variations. The dynamics of weather systems would be different without the axial tilt. Furthermore, the weather and seasonal changes have a significant impact on agriculture in terms of crop planting and harvesting. The absence of seasons can have a big impact on farming methods. In fact, because seasons have a significant impact on plant growth and behavior, plant evolution itself would be changed. Additionally, because they provide food, plants have an impact on how animals have developed. For example, birds frequently lay their eggs so that the chicks hatch at the same time as ripe fruit is on the trees for them to consume. Many living creatures time their reproduction to the seasons. Certain animals would not require breeding seasons or the need to hibernate during the winter. Throughout the year, animal reproduction would essentially be random. The ecology of an ancient Earth might not resemble anything we see today. In the early Earth's history, distinct animal and plant species would have probably been more successful than others, which would have resulted in entirely different evolutionary pathways. It's highly likely that intellectual apes, that is, humans, did not evolve in a setting like this. Instead of us, perhaps some other sentient species might be dominant. If people even existed in such a planet, the Earth's axial tilt would therefore have an impact on biology, evolution, and most definitely human culture. To put it mildly, the world would be drastically different. But what changes may there be in our lives if we were to evolve on such a world as humans? Don Atwood, an ecological anthropologist at McGill University in Montreal, believes that without the help of insects, people would not have progressed beyond a condition of tiny, dispersed villages scrounging for sustenance, and frequently dying horrifying diseases carried by insects. How come this would be the case? According to Atwood, the creation of novel means of staying warm can be considered the ancestor of modern technology. He claims that cold weather encourages creativity. Stoves and furnaces were invented to help avoid winter deaths, carrying on the tradition of men and women gathering around fires in the early days of civilization. The discovery of coal in the 18th century led to advancements in technology and general health by heating dwellings and powering machinery. It resulted in the development of the steam engine and, eventually, the Industrial Revolution, which brought forth the conveniences of contemporary technology. I should point out, though, that not everyone is aware of the connection between cold and technical growth. However, we are aware that the global spread of fatal diseases is halted by winter. For instance, parasites and microscopic creatures perish in the severe winter weather. Many diseases can flourish in an environment that is hot and humid. The HIV virus and the Ebola virus are 2 illnesses that can arise from humid tropical conditions. The proliferation of these illnesses might have disastrous effects for humanity. However, winter has also proved essential to people in other ways. In addition to corn, potatoes, oats, and barley, which all thrive better in regions of the world with cold winters, some types of wheat can only be grown in areas with cool winters. These are the essential foods that keep everyone fed and help avert starvation. If the Earth lost its tilt, there is actually something much more dangerous that may happen. Long-term, Earth could become a snowball. Thank you for joining us on this enlightening exploration of Earth's axial tilt. As we continue to unravel the mysteries of our universe, remember that the subtle tilt of our planet holds the key to a multitude of wonders. Until next time, stay curious and keep exploring the extraordinary mysteries that surround us.